Okay, last video of chapter 10, two new terms. When we're talking about covalent bonds, there are two types of covalent bond, a sigma bond and a pi bond. So here are the definitions. A sigma bond is the head-to-head overlap of orbitals with a cylindrical shape about the bond axis. Sounds complicated, but all you need to worry about is that all single bonds are sigma bonds, okay? So all single bonds are sigma bonds. That's a given. Now let's do the next one. Pi. A pi bond is a side-to-side overlap of parallel p orbitals, creating an electron distribution above and below the bond axis. Again, sounds more complicated than it is. What this is telling you is that when you've got a double bond or a triple bond, one of the bonds is sigma, and then the other one or the other two are considered pi. Okay, so let me show you what an exam question would be like, and then I'll overcomplicate it and show you what all this structurally looks like. Okay, typical exam question. You've got something like this. This is a molecule, C2H4. This is ethene or ethylene. All right, and let's say the question is, how many sigma bonds are there? Remember how I said all single bonds are sigma bonds. So here's 1, 2, 3, 4 single bonds, okay? And then I said that when you've got a double bond, one of them is sigma and the other is pi. So in this one, we have 5 sigma and 1 pi, right? 1, 2, 3, 4, 5 sigma, and then 1 pi. If I had this thing here, which is ethine or acetylene, and they ask you how many sigmas and how many pi's, well, this one is sigma and this one is sigma, and then in a multiple bond, one of them is sigma, and then the other two are pi. So this one has 3 sigma and 2 pi. Okay? So that's what that's all about. Now, let's take this and let me show you what this is actually going to look like. So remember how we said that if it's trigonal planar and this is trigonal planar, can you see? You have 3 areas. If it's trigonal planar, what hybridization do you have? We said it's sp2 hybridization. So what you're going to find for this carbon, let's just say helium, and then we have the 2s, and this is 2p. Remember, carbon looks like this. But now, in order to do a trigonal planar, we're going to have helium. We're going to do sp2. So this will be sp2, 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 and this is p. So we're going to take this guy, bring it over here, but we're hybridizing just 2 of the p's and 1 of the s's. So we're doing sp2, 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 and so 1 electron is still a p. Okay? Keep that in your notes. So how do we draw it? So we've got this carbon that's got an sp2. This is an sp2, sp2, sp2 in this trigonal planar shape thing, okay? And you're going to have a hydrogen with its s electron, head-to-head collision, front collision, sigma bond. Hydrogen with its s electron, head-to-head, sigma bond. Okay? You have the other carbon is over here. He also has sp2, sp2, sp2. Okay? Head to head, remember how we said one of the bonds in the double bond is a sigma. So there's head to head collision. And then here's the hydrogen with its S. And here's the hydrogen with its S. So we accounted for 1, 2, 3, 4, 5 sigma bonds. Okay, where's the pi bond? Remember how we said that we have 3 sp2s, sp2, sp2, and 1 p. So p, remember, is a dumbbell. P is a dumbbell. So remember how we said the pi is a parallel side-to-side overlap with the electrons over and above the bond. So basically this would be considered the pi. So the 2p orbitals do that side-to-side overlap thing, and there you go. You've got the pi bond. You could do the same thing with the acetylene, but you would have 2 pi bonds. So you have to think of the XYZ axes, and you're going to have 2 p orbitals overlapping this way and maybe this way, and then the other is going to be the sigma as an SP. It looks more complicated than it is. I never ask you to actually draw this out. What I will typically ask you is that how many sigma bonds are in this molecule, how many pi bonds are in the molecule, and you should be fine with all of that, okay? So the last part of this chapter deals with molecular orbital theory. I want you guys to read that on your own. I won't be testing you on it, but for those of you who are going to be moving on into organic chemistry, it's good to read through it, just get a feel for what the anti-bonding and bonding and all that stuff is, but I'm not going to cover it in this class. Just to wrap up chapter 10, I'm going to do one quick thing, and then we will be done. All right. What if you have this molecule here? Carbon tetrachloride. And I ask you, what's the hybridization? You can see that it is tetrahedral. Since it's tetrahedral, the hybridization is what? sp3. You don't have to do anything, you just immediately know. So if you know the electron arrangement, if you know the electronic geometry, you immediately know the hybridization. So on a test, if you're given a molecule, figure out its electron, draw the Lewis structure, figure out its electronic geometry, you'll know its hybridization. If it's linear, it's sp. If it's trigonoplanar, it's sp2. If it's tetrahedral, it's sp3. If it's trigonal bipyramidal, it's sp3d. If it's octahedral, it's sp3d2. Okay? Good. We are all set with chapter 10.